Now I am continuing this lesson. Yes? Today we are going to see about compounds. In the last class we have seen about atoms, molecules, types of molecules, definition for atom, molecule, everything we have seen. Now we are going to see about compounds. Yes? So in this class we are going to see about compounds. Yes? So what does compound means? Chemically combined in fixed ratio. Atoms of same element or different element. Chemically combined in a fixed ratio. Yes? So when I explain with the example, you can understand easily. Yes? Let us take one compound which you know, without this we can't live. The best example is water. Yes? You know, water is nothing but two atoms of hydrogen combines with one atom of oxygen to form H2O, which is in liquid state. So water is the only substance which can exist in all the three states, solid, liquid and gas. But now we are taking water as a liquid state. Yes? So what is meant by compound? Compound is nothing but a pure substance which is formed by chemically combined atoms of same element or different element, chemically combined in a fixed ratio. Yes? For example, water, two atoms of hydrogen combines with oxygen, one atom of oxygen to form one molecule of water. So we can say this is a molecule or compound. Yes? So it is a purest substance. So when now I will explain about the properties. So what is compound means? Compound is formed when the constituent elements combine in a fixed proportion or fixed ratio. The second one is the properties of a compound are different from those of its constituent elements. That means if you take water, it is a combination of hydrogen and oxygen. Yes? Very well you know both are gases. Hydrogen is also a gas, oxygen is also a gas. But two atoms of hydrogen and one atom of oxygen combine to form water, which is in a liquid state. So the constituent elements means this hydrogen and oxygen. Both are in what state? Both are in gaseous state. But after chemically combined, it will be existing as liquid state. So the properties of a compound will be different from of the constituent elements. And another important property of water, you know that water is the fire. Water is used as a fire extinguisher. Fire extinguisher means to put off fire. If anything catches fire, to put out fire, what you will do? You will pour some water on it, so the fire will be stopped. Right? So water is used as a fire extinguisher. But if you see this, what is one of the constituent of water? That is oxygen. You know, without oxygen, no substance will burn. Am I correct? In lower classes, you have studied about the property of oxygen. That is, oxygen is the supporter of combustion. In bell jar experiment, the bell jar experiment, do you remember that one? You have to take one bell jar and inside that you have to keep a burning candle into it and it will blow. The candle will burn. Suppose if you close the bottle with the lid, after some time the candle will stop burning. Why it will stop burning? Because no oxygen supply will be inside the bottle. Yes, during lower classes you have studied, no? So oxygen is the supporter of combustion. Combustion means burning, right? But after combining, this oxygen is combined with the hydrogen. After forming water, it is used as a fire extinguisher. So second point, compound, the properties of a compound are different from those of the constituent element. Now another example I will explain. Sodium chloride. Sodium chloride is nothing but a salt which is used for cooking purpose. Table salt, what we are taking Table salt is used for cooking. Without salt, no substance can be eaten. Yes, it will give sweetness, that is taste to the cooked food. You know that one, right? So if you take this table salt, sodium chloride is nothing but one atom of sodium and one atom of chlorine combined to form sodium chloride. After the combination, it will be called that as the chloride, sodium chloride. So this chloride, sodium chloride is used for cooking. That means we are taking as a food, right? But if you take the properties of sodium and chlorine, if you take the property of sodium and chlorine, both are poisonous in nature. Both are very poisonous. Chlorine is in a gaseous form and sodium is in a solid form. Both will combine to form sodium chloride. But this sodium, after formation of sodium chloride, it can be used for eating purposes. And before that, if you take sodium as separately and chlorine as separate element, both are poisonous in nature. So after the formation of a compound, the property will be changing. It will not have the property of its constituent elements. Is it clear for you? Yes? Shall we go to next one? These properties are given in your book, page number 36. If you want to clarify it, you take your book and see that page number 36. And next, third point is, compound cannot be broken down by physical methods. This is because of a compound is made up of different elements and are chemically combined. So sodium chloride cannot be separated by physical methods such as filtration. Yes, so what I am telling, how the compound is formed? Compound is formed by means of combination, that is combination of atoms of different elements chemically combined in a fixed ratio. It is combined chemically. So it cannot separate it physically. We cannot separate it physically. So after the formation of sodium chloride, you cannot separate sodium and chlorine. And after the formation of water, you cannot separate hydrogen separately and oxygen. Is it clear for you? So after the formation of compound, the separation of the elements will not be possible by physical methods. The next one is, a compound can be separated into constituent elements by chemical methods only. It cannot be separated physical method. Physical method means sedimentation, filtration. That also I think you have studied in 6th standard or 5th standard. Filtration. Suppose you are taking one glass of water and we are putting 4 tablespoons of salt into it. We call that as the salt solution. So if you want to separate the salt, what you have to do? You can bring it to boil nature. Yes, you can boil the salt solution. After that, if you keep it as it is, the salt will be deposited at the bottom, and by means of filtration, you can separate water and salt. And likewise, you can separate sugar and water. Yes, is it clear? So that method we call it as physical method. Suppose you are taking sand. Yes, which is having some iron particles also. If you want to separate sand and iron particles using magnet, you can separate the iron particles and sand. So that method we call it as physical method. So like this constituent elements. Constituent elements is nothing but elements which are present in the molecule. So here in sodium chloride, the constituent elements are sodium and chlorine, and this cannot be separated by means of physical methods. Only by means of chemical methods it can be separated. Clear now? So compounds are nothing but the atoms of different elements combined in a fixed ratio. So whatever water you are taking is whether that is, so whatever water means rainwater, well water, bore water, any water if you take, that will have 2 atoms of hydrogen and 1 atom of oxygen. Like the table salt. Yes, whatever salt you are taking, that salt will have sodium and chlorine. So that means it is chemically combined in a fixed ratio. And second property is, the property of a compound will not have the property of the constituent element. That means hydrogen, oxygen in water. Oxygen is a supporter of burning, and if you both are hydrogen and oxygen, both are gases, but you can get the liquid as water. Yes. water as a liquid. The next one is sodium chloride. Before formation of sodium chloride, sodium and chlorine both are poisonous in nature, but after the formation of sodium chloride, it is used for cooking purposes. So these are all the points regarding compounds. In your book, page number 37, they are given the difference between compounds and elements. Now I have explained everything based on compounds and elements we have studied in the last class. So here they are given difference between element and compound. So first point, an element is the simplest substance. Element is the simplest substance. Suppose if you take oxygen, if you take the oxygen as an element, it is the simplest substance. Hydrogen, hydrogen. Sodium, chlorine. So these are all some of the name of the element. All the elements are in a is the simplest substance. But if you take compounds, it is not the simplest substance. It is the combination of two or more atoms. A compound is a chemical substance formed by the combination of two or more elements. Second point, elements combine to form compounds. So here I told you, hydrogen is one element and oxygen is another element. Both combine to form water. Sodium is one element, chlorine is another element. Both combine to form sodium chloride. Is it clear? So, but in the, like compound, if you take, compounds can be split into elements. So I told you cannot separate it by means of physical method, but you can separate it by chemical methods. And third one, atoms are the fundamental particles of an element. I explained about an atom. What is an atom? Atom is the smallest particle which is present, which can take part in a chemical reaction. So atoms are the fundamental particle of an element. But when you take compounds, molecules are the fundamental particles. So these are all the three differences which is given in your book. Then now we are going to see about symbol. Yes. So last class I explained there are 118 elements up to now, today's date, there are 118 elements. So you cannot write each and every element as a name. Yes. So symbol is nothing but a shortest representation of an element. Each and every element we can, instead of write, now we can write. Now if I ask you to write hydrogen, oxygen, chlorine like that, we can write full form, hydrogen spelling HYDROGEN like that we can write. But after that, if you go to higher classes and all, if you write everything in detail, it's not possible to write everything in detail. So they adopted one simple method, that is by writing symbols. So symbol is nothing but a shortest representation of an element. So first scientist who introduced this is Dalton, and but in the olden days, that is during the Dalton period, they used the mathematical shapes and lines like that as a symbol. After that, it is not possible to follow. So now that is IUPAC. IUPAC means International Union of Pure and Applied Chemistry. What is IUPAC? International Union of Pure and Applied Chemistry. On the basis, he approved this IUPAC approved for each and every element they have given some symbols. Yes. So symbols are nothing but shortest representation of an element. So there are three ways to represent they follow three ways to represent a symbol. First way is writing one letter. Suppose these are all some of the examples for writing one letter as the symbol. Name of the element. If it is hydrogen, the first letter is hydrogen H. Yes. So you have to write capital H. First, fluorine F, oxygen O, carbon C, phosphorus P, sulfur S, uranium U like that. Yes, the first letter is taken as the symbol. If you are writing only one letter, it should be a capital letter. Clear? Then second way of representing the symbol is writing two letters. Why we are using two letters means some of the elements will have same letter as the first letter. For example, carbon and calcium. Both the first letters are CC. Like that, sulfur and silicon. Both start with S. So how can you represent both the elements? In that case, they represent it by writing two letters. But when you write two letters, the first letter should be a capital letter and second letter should be a small letter. Yes. So in the second two letter representation, some of the elements I will give you as example. Aluminium Al, arsenic Ar, silicon Si, nickel Ni, bromine Br, calcium Ca letter. Yes. So in your book, page number 38, they are given the table representing, that is elements representing by one letter, two letter, and on third one is Latin name based on the Latin name. So each and every element will have ordinary name and also the Latin name. So based on the Latin name, for example, first one is copper. Already I told, the element starting with C or here carbon and here calcium you have written. Yes. So if you take this copper CO, then you take the another element is there cobalt, that is CO. So both the copper and cobalt started with CO. In that case, you cannot add third letter COB like that. It's not possible to write. In that place, in that case, what they have done, they use the Latin name. For copper means cupra. Cupra means CUPRUM. The first two letters is taken as the symbol for copper. Like that, aurum. Aurum means gold. The Latin name for gold is aurum. The symbol for that one is AU. Like that, iron. For iron, IRON you will be writing as a straight name. But the Latin name is ferrum. Here they are writing first two letters F and E. This is very important. Unless and otherwise you understand this symbol, you cannot write chemical formula or chemical equation. You cannot even study chemistry at all. Okay, so it is very much important. You rewind this video and often you hear that. Then only it will be going into your mind. Yes. So here symbol is nothing but the shortest representation of an element. So Dalton only introduced this way of writing the symbols. Now IUPAC is there. Here you can represent the elements by means of writing one letter or two letter or Latin words. It is given in your book in the table. You have to mark it up. Then only you can write. Whenever I ask what is the symbol for carbon, phosphorus, sulfur, potassium like that, immediately you can say. So for that one, now you are having plenty of time. Just you take this table and by God. Okay, the next one is chemical formula. Only if you know symbol, you can understand chemical formula. Yes, chemical formula is nothing but a representation of a molecule. What is symbol? Symbol is the shortest representation of an element. But what is chemical formula? It is the shortest representation of molecule. For example, if I say water, instead of writing WATER, you can write H2O. Instead of writing sodium chloride, you can write NaCl. Yes, sodium, the symbol is Na. Chlorine, the symbol is Cl. Both combined to form sodium chloride. So the chemical formula for this, that is NaCl. Like this water, what are the constituent elements present in water? Hydrogen and oxygen. How many atoms of hydrogen? 2 atoms of hydrogen. How many atoms of oxygen? 1 atom of oxygen. So you have to write H2O. What is the chemical name for? Chemical formula for sodium chloride means NaCl. Chemical formula for water means H2O. So chemical formula is nothing but the shortest representation of a molecule. Shortest representation of a molecule is called as the chemical formula. Is it clear now? Shall we go to next one? Next one is atomicity. The word atomicity. Atomicity is nothing but number of atoms. What is it? Number of atoms present in a molecule. Number of atoms present in a molecule, we call that as the atomicity. For example, if you same example you can take sodium chloride. Here how many atoms of sodium? 1 atom of sodium. How many atom of chlorine? 1 atom of chlorine. So the atomicity of sodium chloride is 1 plus 1, 2. Clear? Like that, if you take water, 2 atoms of hydrogen and 1 atom of oxygen. So 2 plus 1, 3. The atomicity of water is 3. Like that, sulfuric acid means the chemical formula for sulfuric acid. First you have to write down. To find out the atomicity, first you should know what is the molecule. Second, you have to know what is the symbol for the constituent element. Next, you should know what is the chemical formula for that element. Then only you can understand the atomicity. For writing sulfuric acid is nothing but H2SO4. That means 2 atoms of hydrogen, 1 atom of sulfur and 4 atoms of oxygen. So how many atoms totally? 2 plus 1, 3, 3 plus 4, 7. So the atomicity for sulfuric acid is 7. So simply they will ask, write the atomicity for hydrogen chloride. Write down the atomicity for sodium chloride like that. Only if you know the chemical formula, you can write the atomicity. So whatever example given in the book, that alone you read. That will be useful for you. Right? So atomicity, what is the definition? Total number of atoms present in a molecule, we call that as the atomicity. Okay, this clear now. Shall we go to next one? Next one. If you take our body, 99% of our body is having these 6 elements. So what are all the elements present in our body means oxygen, carbon, nitrogen, calcium, phosphorus and hydrogen. So these are all the elements. Totally all these elements are present in our body by means of 99%. The left out 1% is a combination of potassium, sulfur, sodium, chlorine and magnesium. So these are all the elements totally present in our body. After this clear? So we go to next one. Next topic is effect of temperature on solid, liquid and gas. So what are the 3 states of matter? Solid, liquid and gas. That you know. I explained, you studied the lower classes also, and when I take what is that before lesson, before topic itself I explained. So what are all the 3 states? Solid, liquid and gas. So if you take this state, the first point regarding this state is arrangement of molecules. What is that? Arrangement of molecules. So if you take solid, any solid, if you take any solid, in solid, all atoms are packed tightly or arranged in a tight manner. There will not be any space in between the molecules. Suppose if you take this book, whatever solid substance you take, in that substance, all the atoms are tightly packed. All the atoms are tightly packed. There will not be any space between the molecules or atoms. Clear? The next one is liquid. If you take liquid, in liquid the molecules are loosely packed. Like that. Yes, the molecules are loosely packed, and in gases, the distance between the 2 molecules will be more. Yes. So based on the arrangement of molecules, I can explain this effect of temperature. So what is meant by temperature? Temperature means how will you raise the temperature? Only if you supply some heat energy, the temperature will be increasing. Am I correct? Only if you ignite something, if you supply some heat energy to any substance, the temperature of the substance will be increasing. So first we will take, here also we take water as the best example. Yes, water in a solid state means what state? Ice cube. If you take the ice cube, in ice cube all the molecules are, all the atoms are tightly packed. Yes, if you want to take the ice cube from the ice tray, just you have to knock it, then only it will come out. Isn't it? Why we are doing like that? Because it is tightly packed. If you want to break it, you have to use some stick, then only you can break the ice cube. That means you have to supply more energy to break the bondage. Am I correct? So in solids, all the molecules are tightly packed. So suppose if you are taking solid ice cubes, and if you heat it, you are taking one pan and you are putting some ice cubes into it, or otherwise just you keep it on the table. What will happen? When you take it from the fridge, it will be in a solid state. After 10 or 20 minutes, you can observe that the the ice cubes will start melting. Isn't it? Melting means it will be converted from solid state to liquid state. Am I correct? It will start to, that is, the ice cube will absorb heat energy from the surrounding and it will reach the room temperature and starts melting and it will be converted into liquid. That means if you supply some heat energy, what will happen? The atoms which are present in the solid tightly packed will move apart. What is happening? It is vibrating. Move apart means it starts to vibrate. It is accepting the heat energy and the atoms will move apart. So now it started to move and it is reaching the liquid state. In liquid state, all the molecules are placed in a loose manner. Again, if you start heating it, what will happen? The water will be converted into water vapor. When it reaches the gaseous state, still the distance between the molecules will be increasing. So what is happening? When the water starts to boil, you can observe that vibration, isn't it? When you boil water, it will start jumping. Yes? So if you are having a lighter substance, lighter pan like that, the pan is also started to jump. Isn't it? So that is, it is vibrating gently. So effect of temperature in solid and liquid means if you supply some heat energy to the solids, the molecules which are present in the solid state will accept that heat energy and it starts vibrating. If you take liquid, if you supply heat energy to liquid, already in liquids the distance between the molecules are more and now it is accepting the heat energy and the vibration will start and still the molecules will be moving apart. And if you take a gaseous substance, already the gaseous substance will have the molecules will be placed, the distance between the molecules will be more and now it is started vibrating. So when you take this example is, when you take hot balloons, the hot balloons will be, when you take the balloon and if you fill it with hot water, what will happen? It will go up. Why it is going up? Because it started vibrating and it is lighter in weight, so it is moving upward. Clear now? So in page number 41, it is given solid, liquid and gas, what are the effect of temperature. So by this I am concluding this lesson. So we have completed the lesson matter around us. So it will be very interesting. Unless and otherwise you understand, you cannot proceed it. So just you are having plenty of time to take a book, you improve reading. Just you read line by line, then you can understand this one. So what is the homework for you means, to take page number 42, in the evaluation part choose the correct answer, then fill in the blanks, both the way it's given and also true or false and also answer in a brief also a simple one only. Yes, so you take this one. Before I am sending that notes, you just take pencil and you mark down the answers. After I send the notes, you can verify with whether you have done it correctly or wrong. Okay, that is the homework for you. Just you do it. You take that book, read line by line, understand it properly, and find out the answer using the pencil and write it in the book itself. Yes, then only you can. If the answer is wrong, means you can rub it and write. Okay, children. Thank you.